You know that device you're watching this on right now? Your phone, your computer? It all boils down to one simple thing, our ability to control something we can't even see, the electron. So today, we're going to go way back to the beginning. We're talking about a simple glass tube that first managed to tame this invisible force and, well, basically kick-started the entire modern world. All right, let's get into it.
So, here's the game plan. First, we'll get to know the tiny particle that makes all of this tick. Then, we'll see how a super famous inventor, totally by accident, found a huge clue. And from there, we'll follow the breadcrumbs to the very first devices that didn't just turn electricity on and off, but could actually make it stronger. And that, my friends, changed absolutely everything.
Right, so before we can even get to the cool stuff like vacuum tubes, we gotta start with the basics. What's actually inside them? What's doing all the work? It all comes down to the electron.
Okay, so take a look at this. It's like a little blueprint for, well, everything. In the middle, you've got the nucleus. That's where the protons and neutrons hang out. But for us, for this story, the real action, the stars of the show, are these little guys whizzing around on the outside. Those are the electrons. And here's the thing you really need to get about electrons. They are ridiculously small and super lightweight. That means they're easy to push around. And when you get a whole stream of them moving together in one direction, boom, that's it. That's electric current. The whole secret, the key to all modern technology, is just figuring out how to control that flow.
So you'd think the first big step in controlling this flow came from some genius plan, right? Nope, not at all. It was a total, complete accident. And the person who stumbled upon it? None other than Thomas Edison. And the funny part is, he was trying to solve a totally different problem. See, Edison wasn't thinking about inventing electronics. He was just annoyed that his light bulbs kept burning out, so to try and figure out why, he did something weird. He stuck an extra little metal plate inside the bulb. And that's when he noticed something bizarre. A current, an electrical current, was somehow jumping across the empty space, the vacuum, from the glowing hot filament over to this new plate. He called it the Edison effect, even got a patent for it, but he had no idea what it was good for, so he just put it on a shelf and moved on.
But here's the absolute golden nugget from his experiment, the thing that would change the world. That weird current, it only flowed one way. It was like a one-way street for electricity. Now, Edison didn't get it at the time, but he had just stumbled upon the core principle of the very first electronic switch. So Edison drops this huge clue and just walks away. Now let's see who picked it up and ran with it, turning this weird little science curiosity into something that would literally change the world. Okay, so enter John Ambrose Fleming. Now, Fleming was wrestling with a massive challenge for his time. How on earth do you detect those super faint signals from the early days of radio? They were just too weak. And then a light bulb went off, no pun intended. He remembered Edison's weird one-way current thing, and he had a eureka moment.
So he took Edison's basic recipe, right? A hot filament, a metal plate, all sealed up in a glass vacuum. And in 1904, he built this thing, he called it the Fleming valve. And what you're looking at is the world's very first vacuum tube. Today, we just call it a diode. Its job sounds simple, but it was absolutely revolutionary. It was basically a bouncer for electricity. It would let the current go through one way, but if it tried to come back, nope, doors closed. This process is called rectification, and it was the magic trick they needed. It could take a messy, choppy radio signal that's alternating currents, or AC, and turn it into a smooth, steady, usable signal, direct current, or DC. It was the perfect filter for those faint radio waves. So the diode was amazing, a perfect on-off switch. But the real game changer, the thing that unlocks the true power of electronics, isn't just turning a current on or off. It's about being able to control how much is flowing with real precision. And for that, they needed one more ingredient. And it only took 2 years. In 1906, an American inventor, Lee DeForest, had this brilliant, almost simple idea. He thought, what if I stick a third thing in there? He added this little mesh screen, a grid, right in between the filament and the plate. He named his invention the Audion, but you and I know it as the triode. And this one tiny addition, that little grid, changed literally everything. If the diode was a light switch, just on or off, the triode was a dimmer. You can now control the flow from a trickle to a flood. It gave us nuance. This faucet analogy is honestly the perfect way to think about it. Imagine the electricity, Those electrons are water flowing through a big pipe. That little grid that DeForest added, that's the handle on the faucet. With just a tiny bit of effort, a tiny twist of the handle, you can control a huge, powerful flow of water. That, right there, is the magic of amplification. So by putting just a tiny little electrical signal on that grid, you could suddenly control a much, much bigger flow of electrons from one end to the other. So what does that mean? It means you could take a super weak signal, like a radio wave from miles away, feed it to the grid, and get a huge, powerful signal out the other side, strong enough to make a speaker cone move and create sound. This was it. This was the breakthrough everyone was waiting for.
So now we can switch electricity and we can amplify it. With those two powers unlocked, the world was about to change fast.
All of a sudden, these little glowing glass tubes were everywhere. They were the heart and soul of the new technology. They were inside the radios that brought news and music into living rooms for the first time. They made it possible to call someone across the country. And they were the fundamental building blocks for the first massive, room-sized electronic brains. Computers like the legendary ENIAC.
And this idea of amplification was just so powerful. I mean, the tech that eventually came after the vacuum tube, the transistor, was really just a much, much better way of doing the same thing, making signals 100 times stronger. But we can't forget that the whole concept, the very idea of amplification, it all started right here, with this fragile glass tube.
And this quote really nails it. Think about it. Before this, electricity was just dumb power. It was for making light or spinning a motor. Brute force. But after the vacuum tube, electricity got smart. It could carry information, it could carry our voices, our favorite songs, and eventually our data. Electricity went from being a workhorse to a messenger. But, for all their revolutionary power, vacuum tubes were kind of terrible. They were big, they were fragile. I mean, they're basically light bulbs, and they got super hot. They used a ton of energy. So yeah, the electronic age had definitely started. But to get to the world we live in now, we had to solve these problems. We needed to take all that power and make it smaller, faster, and way more efficient. Which leaves us with a pretty big question. How did we go from a room full of glowing glass tubes to a chip that fits on your fingertip?